Hello guys, this is Mrs. Braband. I am going to show you some examples for our Unit 1 target sheet. So what I'm going to do is kind of run through in pieces each target. So you will see this college algebra target sheet called Linear Equation Summary in the Google Classroom. It's not a homework assignment that you need to do. It's simply a summary page so that you can use this video and print it out if you'd like to and get some practice if you're struggling. These are things that you'll need to know for your assessment. So we're going to start with example 1 and realize that the only thing that's kind of tricky here is we got to take care of that distributive property. So we're going to distribute 5 to both cases. That's going to get us 5x plus 15. There's nothing going on different for the right side, so I'm just going to write it out. And then I can realize, all right, I need to start moving variables around because I'm trying to isolate the variable. I like to move my small to my large when it comes to variables. That just seems to keep things nice and positive. It's easier, in my opinion, excuse me, to deal with positives than it is to deal with negatives. I just prefer it. So isolating the variable, we got to move this 29 now. That's going to give us a 2x isolated there. This is going to be a negative 14. And now you just need to divide both sides by 2, and you end up with negative 7 equals 1x, which is great. Now, ordinarily, if we were first learning this, we would have you take that 7 and go back up and substitute it into each side and make sure that that balance the equation to make it equal. Is the left number really equal? I'm not going to insist on that, but I do suggest if you are struggling and you just want to double check, that might be a good way. There are other ways that I can show you later, like plugging it into Desmos and watching how the lines line up. That's kind of interesting. We'll do that another time. All right, so for this guy, I know a lot of people run and scream from fractions, but don't worry, I'm going to work this out for you and you're going to see how this works. We have to make a common denominator, which is called a lowest common denominator, but it's also known as a lowest common multiple, which I prefer because it tells us what we need to do on how to figure it out. So when you look at a least common multiple, you need to use one of everything you see in that denominator and work that out. That way you're going to turn all the numbers in the denominator to the same number. So it looks like we're going to be all turning to 70. I'm just going to get that ready. Watch how I do that. I'm just going to get it ready, keeping the signs, keeping the fraction bars. I know 70 is going to be coming up because that's my goal. And then I can figure out what the new numerators are going to be after I do the multiplication on top. So when you multiply on top, I'm going to move this, okay? You say, what did I have? 7. What do I need? 70. I'm missing a 10, so I need to multiply by 10. Where did I get that 10? Look up here. I had the 7. I need the 10. That's where I got that. So that gives me a negative 60 on top. Going to the second fraction right here, it has a 5, but it's missing the 7 and the 2. So we need to multiply the top and the bottom by 14. That'll give us negative 28x on the top. And as we know, it's already 70. So you've got now this equal sign here. You got a 2 that was given, but you're missing the 7 and the 5, which is 35. That way there's that beautiful 70 on the bottom, and now you've got a negative 35 on the top. The great thing about this is now you've got common denominators, and you can start combining like terms. And there's a lot of ways to do this. I could move the 60 over and combine like terms and then cross multiply. But I want to show you a step that not very many teachers work with, and I think it's kind of convenient. And I just want to show it to you. If it doesn't work, we can do it another way, another time. I like the 70s. They're beautiful and matching now, but I don't want them there. So I can get rid of them all at the same time. I can undo all the division at the same time. I can only do that because they're all the same numbers. I couldn't do that up here. They're not the same. So what I can do is multiply every single thing by 70, multiply it all by 70, multiply it all by 70, and look, reduce, 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 meaning I divided it out. And when I divide that out now, as long as I balance both the left side and the right side, that's completely legal. And so now that I've divided everything out, look, they all go away, and I've got this pretty little equation that's just like the one in the front. And now this is easy for me to say, hey, I'm going to move 60. So I've got negative 28x equals positive 25. Now I can divide. And even though that's not a beautiful number, I'm going to put it over here. I have x on the left, and that's 25 over negative 28. And that is my solution to isolating the x up there. So that means if I actually substituted it in there and did my math, the left side would match the negative 1/2. Again, you can try that on your own if you want. Please be aware that in college algebra, you guys, we tend to embrace the numbers that look kind of messy. We embrace a lot of distribution. We embrace a lot of fractions. All those things you used to skip in your other classes because they were maybe too hard back then. We jump and go in college algebra because we have to make sure that you're ready for that rigor in college. All right, the last one here is just kind of like the first, but it's got an extra set of distribution. So negative 4x plus negative 4 plus 6x. We don't take it to the 6 because the parentheses is like a stopping point. I'm sorry, that's 6x. And then 2x plus 4 minus 8. Again, we don't use the 8 because that parentheses is a stopping point. It's like a wall. And then I just say, you know what? I need to clean things up that look alike. So any like terms on the left I do, and any like terms I do on the right. So the x's on the left, excuse me, are going to turn to 2x. Sorry. The right side, ooh, new voice, is going to be 2x minus 4. So the cool thing, excuse me, let me take a sip. Oh, that water helps. Apologies. The cool thing is that these sides balance, which we don't usually see. But what that really means is if I start subtracting everything, I get this 0 equals 0, which means this is a true statement, and I like that it's true. So that means any number that I want to use works. So I have infinitely many solutions, or sometimes you'll see somebody write all real numbers. They'll put a big R like that for all real numbers. That's kind of neat. So I'm going to stop the video and link this for you so that you can have it to watch if you want to over and over again until it makes sense. And then we'll do the next.